less than 10 seconds.
Hey everyone, Michael here for the H.R. MacMillan Space Center. Once again, joined for our weekly activities with Morgan from Let's Talk Science. So let's talk science with Morgan. Hey Morgan, how are you?
Good, how are you?
Oh, I'm just doing great as we have now reached into summer now. It doesn't quite feel like it's today when we're recording, but we are officially in summer. This week's theme is asteroids. And this does coincide actually with not really a holiday. It's not really a day of celebration. It's more of like a day of observation. June the 30th is Asteroid Day. And the reason it is Asteroid Day is because on June the 30th, the early 1900s, there was a very large asteroid strike that hit the Earth. Luckily, it hit in Siberia where nobody lived. And for many years, actually, we didn't even know that there was a strike until scientists went there and realized this whole area of force was just leveled. And if there were people living there, that would have been bad news. And an asteroid strike of that size, if it strikes again, they say it usually happens about one every 100 years. So, I mean, we're kind of due for another one. So it is more of a day of observation for us to understand that we need to know more about these flying rocks out there in space. And this week, you've got a really good activity for us to help us understand that.
We've kind of got the perfect activity for it. So we're looking at how different sizes and different velocities, if you will, of asteroids can influence how much they will impact the Earth should they strike at any given time. And yeah, we're really exploring the process of scientific inquiry again, trying to get youth involved in asking questions or making hypotheses, we call them, and then validating those through doing controlled experiments.
Awesome. And plus, I would love to see, I'm sure, Morgan, you'd love to see any of the kids or adults out there that have been conducting some of these experiments. Maybe send us some pictures, send us a little note to see what you created. And of course, you just mentioned something really important, the process of scientific inquiry, Morgan. So you must have gone through that process as well, delving into this topic.
Oh yeah, a whole lot. So I was really asking myself, do like different densities of what we use for asteroids influence how big of an impact they can make on what we're using as the Earth? And just looking at different physical characteristics of different rocks and so on, looking at how big the craters are that they make upon impact.
Yeah, absolutely. And the thing is, we don't actually know a lot because a lot of these floating rocks, they are very varied. There is a mission right now going to, it's called OSIRIS-REx, and it's going to an asteroid called Bennu. And this mission is really cool. It's actually going to land on the asteroid, take a sample, and then bring it back to Earth. Which is a lot easier for us to study an asteroid rather than just wait for a rock to impact the Earth, because that, for the most part, that's how we study these things. But it's a really amazing mission, and right now it's scanning the whole asteroid, trying to find a good landing spot, and then it'll sort of vacuum up a whole bunch of material and come back. It's going to be a really cool mission.
Wow. Whereabouts is that asteroid?
Well, it's in space.
Yeah.
It's sort of it's in a solar orbit, so it is orbiting the sun, and it's not quite far as Mars, but it's out there in that region in between us and Mars.
Interesting. So is there an idea that it could possibly strike Earth one day, fall out of that orbit and into our atmosphere?
Absolutely. So obviously, when they announced this mission, they sort of underwent a process of trying to choose which asteroid they wanted to visit. And of course, that was one of the criteria, was that, there is a small percentile chance that this asteroid may go into an Earth orbit. And the really cool thing about finding these asteroids is the prediction model, so that they can actually use math to show where their orbits are going to be, and then extrapolate for many, many years into the future, and then say in 1,000 years, Bennu has maybe a 5% chance of hitting the Earth. I don't think it's as high as that, but
I was gonna say those are pretty good odds.
But 1,000 years, but So it's that kind of extrapolation models that go into trying to find these objects. Of course, the really dangerous ones are the ones that we haven't found yet. And they're the ones that will probably come in from the outer solar system. So really, the main purpose, I think, right now for planetary defense is to create more of these planetary telescopes just to find the asteroids.
Interesting. Okay. Well, without further ado, on that note,
let's get to this week's activity all about asteroids.
Hi everybody, so this week we're learning all about asteroids and more specifically how the size of asteroids influence their impact on the Earth and how that relates to the relative danger of us being hit by an asteroid here on Earth. So asteroids are commonly confused with other things such as meteorites and even shooting stars, and we're going to clear up some of those misconceptions today. So first of all, an asteroid is a flying piece of debris in our solar system that is not large enough to be considered a planet and likely is going to burn up upon entering the atmosphere of another planet. So unless an asteroid is greater than 40 kilometers in diameter, its penetration through Earth's atmosphere will cause it to incinerate and burn up before it strikes the Earth. And that really makes up most of the asteroids that we find in what is known as the asteroid belt, which is a large expanse between Earth and Jupiter. Now, what's a meteorite? A meteorite, in contrast to an asteroid, has a trail of debris that follows it as it moves about in our universe, our solar system. As well, shooting star is actually an asteroid and is something that we might see as we look up into the night sky, an incinerating asteroid flying through the sky, and again, unlikely to ever actually strike the Earth because it will burn up before it reaches Earth's surface. Although most asteroids in the asteroid belt are small enough that they would incinerate before they reached Earth's surface, there are more than 200 in the belt that are more than 100 kilometers across. So these pose a real risk of being able to enter into our atmosphere and strike the Earth and cause some damage. Last time the Earth was hit by a destructive asteroid was millions of years ago, about 65 million years ago, when a meteor 6 miles across hit the Earth at a basin in Mexico, which resulted in the mass extinction of dinosaurs. Fortunately, scientists predict that your chances of being killed by an asteroid are very low, 1 in 40,000, and currently no known asteroids are on a collision path with Earth. However, every 1 or 2 million years, the Earth could be hit by an asteroid large enough to cause global destruction and kill most people alive. To prevent this, engineers seek ways to destroy or divert asteroids before they hit us, just like in the movie Armageddon. Now, asteroids can range in size. The smallest we know of is only 6 meters across, which would easily fit in your classroom at school. And the largest we know of right now is 933 kilometers across. Let's think about that, 933 kilometers. If you were to drive from the city of Vancouver for 933 kilometers, where do you think you'd end up? Look it up, leave it in the comments below for us, and maybe that will put into perspective for us how large these large asteroids really are. Asteroids in the outer part of the belt are composed mainly of carbon, while those located at the inner part of the belt are made primarily of minerals, since they are derived from melted objects. Although scientists are not certain how asteroids came about, it is believed that they are results of collisions of much larger objects occurring around the time that our solar system was formed. Researchers at NASA have been actively tracking near-Earth asteroids to determine whether or not they will hit. Jupiter's gravitational field pulls on asteroids just enough to slowly change their trajectories. With the advancement of computer models and tracking devices, scientists can predict the future trajectories of asteroids. And like we mentioned, they have found that no asteroids are on a collision course with Earth as of right now.
Now we're going to do an activity where we explore how the different size of
asteroids and their different speeds might impact how they hit the Earth's surface should they survive through penetration of the atmosphere and strike Earth's surface. So what you're going to do is take 4 rocks of different sizes, but preferably the same densities, which you can do by picking smaller rocks made of minerals that are heavier and larger rocks with minerals that are lighter, which will give them about an equal density, since density is the relationship between the mass and size of an object. Now, once you've got your 4 rocks, we are going to use as our Earth's surface. Now, in a 2 foot by 2 foot container, you're going to collect some sand or dirt. I've used potting soil here from my outdoor garden, since that is what I have available to me at home. And you're going to fill it about 1.5 inches with your soil or gravel or dirt. And then, again, in your lab notebook, create a table for recording the size of the crater that each rock will create when dropped from the same distance. And now you do the experiment. So starting with our smallest rock, rock 1, we're going to drop it from shoulder height. So again, it's super important to keep this consistent for this part of the experiment. When we drop it in the earth, it creates a little bit of a crater. It doesn't really exceed much of the size of the rock itself, but then taking our ruler, we're going to measure that and record it in our lab notebook. And then you repeat the process for your larger rocks. So rock number 2. And so on and so forth. And then again, we can repeat the same experiment. This time, if we just select one of our rocks and we change the different heights from which we are dropping it into our Earth's surface, we can get an approximation for how the different speeds of the asteroids might influence their impact on Earth's surface. So starting lower than my shoulder, perhaps measure the size of the crater created, and then increasing back to shoulder height, and above perhaps to eye level. And now I can see just qualitatively that the craters are getting larger, which would suggest that the speed of the asteroid positively influences the size of the crater created by the asteroid should it strike Earth's surface. If you'd like to get a bit more creative and crafty with your asteroid experiment, you are welcome to paint your rocks that you're using to model your asteroids, or even create your own asteroids out of some modeling clay and other materials like beads and small pebbles perhaps. And think about, according to the reflections in the PDF instructables attached to this video, think about what those different materials might represent. Again, going back to our discussion about how the different asteroids occurring in the different parts of the asteroid belt are composed of different minerals, perhaps. If you tried out this experiment at home, let us know what you found about the size of asteroids and their speed, and how that might lead us to making accurate predictions about how different asteroids out in space that we are monitoring could influence us one day, and perhaps what sorts of technologies engineers might need to create in order to prevent those collisions from occurring. Otherwise, thank you guys for tuning in, and we will see you next week.